This is LING 270, Language, Technology, and Society, Module 6, Artificial Intelligence. In this lesson, we'll talk about the early history of artificial intelligence. The development of machines which can exhibit human-like behavior is not really a new development. In fact, there are machines that have been developed with the intention of being human-like that have been around for centuries. So we'll be discussing those in this lesson and talk about the automata that were developed during the scientific revolution. And while these automata were being developed, we saw that some philosophers began to comment and speculate on their ultimate abilities. And we'll see some striking similarities as to what these philosophers are saying and what philosophers and thinkers are saying now with regard to artificial intelligence. And we'll also notice in the early history of AI some early developments in attempts to systematize knowledge, so creating formal systems that can describe information. In particular, the development of formal logic, which was a critical development that was important for the development of computer programming, as we'll see later on. So let's start talking about the idea of automata. So automaton is a Greek word, automata is the plural, and it means self-moving. So these machines were basically designed to follow a course of movement, so they were basically automatically doing a particular action instead of being moved by a tool that was just moved by a person. Very frequently, these kinds of actions would mimic humans. So some examples of automata that we might think of would be things like cuckoo clocks, which might have complicated mechanical devices in them, which occur at predictable intervals. We also see automata that were developed, such as the woman seated in the top right here, which was capable of performing handwriting in a manner that was very similar to humans. A music box could also be an example of an early automata. So these kinds of automata were developed during the scientific revolution, when there was a lot of advancement in the knowledge of science and mechanical engineering. Now, the important thing to note is that initially, these developments tended to be more decorative than practical. So practical automata wouldn't be developed for another 100 years. So that's an important thing to keep in mind. And it was during this time when the Mechanical Turk came around. Now, Mechanical Turk is the namesake for the Amazon service today. So I'll discuss where that name came from. So the Mechanical Turk was a device that was designed by Wolfgang von Kempelen, and it was intended to impress Empress Maria Theresa of Austria. Now, Mechanical Turk was designed to appear as if it was an automaton, but in fact, it was not an automaton at all. The box that you see in this image here actually contained a cavity where a person could sit inside and move around the mechanical components to make it appear like an automatic machine that could play a game of chess. However, the machine, in fact, could not move by itself. It had to be controlled by the human inside of it. So this name Mechanical Turk came to signify something that appears to be a machine when in fact there is a human being behind the scenes that is doing the work. So this is the namesake of Amazon Mechanical Turk, which is a crowdsourcing platform. So if you provide a question or a task to Amazon Mechanical Turk, Amazon will present that task to a bunch of humans. The humans will then complete that task, and in that way it will kind of seem like that task has been completed automatically, but in reality there is a human behind the scenes. So this Mechanical Turk here is something that developed while these early automata were being developed. So that's an interesting development to be aware of. And while these automata were being developed, we see some interesting kind of commentary that philosophers made, which actually is remarkably similar to the commentary that we can see today. So here's Rene Descartes commenting on the abilities of automata. So Descartes says, how many different automata or moving machines can be made by the industry of man? For we can easily understand a machine's being constituted so that it can utter words and even emit some responses to action on it of a corporeal kind, which bring about a change in its organs. For instance, if touched in a particular part, it may ask that we wish to what we wish to say to it. If in another part, it may exclaim that it is being heard, and so on. But it never happens that it arranges its speech in various ways in order to reply appropriately to everything that may be said in its presence, as even the lowest type of man can do. So here we see an interesting idea being expressed by Rene Descartes. So Descartes notes that we can make these machines that can exhibit very complicated behaviors and can appear to mimic human behavior. But Descartes argues that real human behavior, such as have linguistic abilities, being able to have a conversation, is something that is something that a machine would not be able to do. So here we see an early on skeptic of the ability of machines being developed that are intelligent in the same way as humans. And we can see probably many philosophers, even in the present day, which we'll discuss, which would agree in principle with the same kind of things that Descartes is saying here. So this is an interesting development to keep in mind. And now, as I had said at the outset, the many early automata that were developed were not really built for any practical purpose. However, we do see some examples which were designed for more kind of practical purposes, in particular, performing large mathematical operations. As early as 1642, we see Blaise Pascal designing the first example of a kind of mechanical calculator. So Pascal was a tax collector, and he noticed that there was a very large amount of arduous calculation that needed to take place when collecting the taxes in France. So he recognized very quickly that this is a task that would be very beneficial to automate. So he invented the device in the center right over here, which is capable of performing addition and subtraction, and it contains a carry mechanism, which is the same kind of which is used to do the mathematical operations when we carry digits, when we do manual addition, like we learned in elementary school, for example. It uses the lantern gears, which are the gears that you can see in the top right here. Now, although this machine could only do addition and subtraction, we see that it is really a huge advancement, and a very early one, in fact, of using these automata's abilities to performing a kind of what we might consider a complex task, being able to do mathematical operations. And then later on, we see in 1672, we see that another calculator being, or an early version of a calculator being designed by Gottfried Leibniz. And this machine could not only be capable of addition and subtraction, but could also perform multiplication and division. Now, Leibniz had simply designed the machine, and many argue that the mechanical development at the time wouldn't have been able to build a system as complex as Leibniz had designed it, but modern replicas have been able to be produced, and so we can see that the idea of making a machine that can do mathematical operations, a kind of human-like operation, is actually hundreds of years old. And more recently, we see a development of a more of another kind of machine which can perform calculations, but of a more general kind. So this is what is called Babbage's analytical engine. So Charles Babbage is one of the pioneers of developing computing machinery. He lived in Britain in the late 1800s, and it was designed not just to perform addition, subtraction, multiplication, and division, but it could perform a variety of simple tasks. And these simple tasks could be combined and rearranged with each other as specified by a kind of program. So the functions that the machine actually does wouldn't be the same function every time. It could be changed based on what kind of program you gave it. In a way, you could we can think that this analytical engine is really the first designed example of a computer, because it could take a kind of program that specifies what actions it should take. And it's notable here that the mathematician Ada Lovelace, very famous in the field of computer science, wrote the first program for this designed analytical engine. So Ada Lovelace's program can, in some ways, be considered the first computer program ever written. Like Leibniz's calculator, the analytical engine was something that was so complex that it was never actually built. Babbage got funding from Parliament to do the initial work, but ultimately he was not able to finish it. Replicas have been made in the modern age, and you can find some demos of these in the History of Computing Museum. So those are kind of an interesting thing to look at as well. So here we see that even hundreds of years ago, we have early developments in machines which can perform complex mathematical tasks, and machines which can be programmed to do different tasks. And as I've said at the beginning of this lesson, a lot of the early development of AI involved systematizing meaning. So in the 1600s, we see developments to create this thing called a universal language. This was an idea that was developed during the Enlightenment, and it asks the question, is it possible to produce a system which can directly encode thought? So we know that language can kind of encode thought, but our language has a lot, our natural languages rather, have a lot of ambiguities and imprecision to them. So these early philosophers in the Enlightenment wondered if it was possible to create a system, a universal language, which could express meaning and ideas directly without any of these imprecisions and ambiguities of natural language. This idea actually has biblical roots. So it's believed that according to the record of the Bible, that the language that humanity spoke prior to initially was a universal language like this. It was something that could express meaning directly, and humans use this kind of communication to try to build a very large tower that could reach the heavens. This was something that according to the Bible, God wasn't happy with, and therefore caused humans to speak different languages so they wouldn't be able to understand each other and collaborate with each other to build the Tower of Babel. So these Enlightenment philosophers had wondered if it was possible to uncover what this universal language was. Can we find a way to express meaning directly with a symbolic system? And what such system, or at least some properties of it, were described by Gottfried Leibniz as well in his work called the Characteristica Universalis. So those were the early developments in attempts to systematize meaning, but a few hundred years later, we see some more concrete developments, namely in the development of the field of formal logic. So the field of formal logic aims to represent logical meaning using a mathematically based system. And so this represents meaning systematically, mathematically in this way. Some formal logicians would include the George Boole, who if you are a computer science student, you may be familiar with this idea of Boolean logic. He was the originator of that. published his work about this in The Calculus of Logic. And we also see some developments by Gottlob Frege, who developed the foundations of predicate logic. So this kind of is a way of distilling out some of the logical properties that we see in natural language. And we also see the logician Bertrand Russell and Alfred Nord Whitehead, who further revolutionized formal logic with their systems as well. And these developments in formal logic became critical to computer programming. A lot of these concepts are things which are used in computing machines. So the big idea of making a formal logic system is finding a way to systematically represent meaning. And if you can represent meaning systematically, then that means it's possible to develop a machine which is capable of understanding it fairly easily. So these logicians were critical in developing these fundamental ideas that could do this. So if you aren't familiar with the idea of formal logic, formal logic has to do with, Boolean logic has to do with these ideas of things. If X and Y is true, or then that means that refers to the intersection of those properties, or it also refers to properties such as or not. So we can see how these kind of basic building blocks of and, or, and not can kind of combine to form more complex logical expressions. And these are important in making a lot of electronic circuitry as well. So there are some electronic circuits which will produce an output if it receives an input in its A or in its B for input, for example. So we can see that we can design electronic circuitry which can kind of mimic this logical behavior. And this is really important to the development of some computing machinery. Now, predicate logic is something that was developed by Gottlob Frege, as I had said before, and this kind of aims to express things that natural language tends to express. So predicate logic uses quantifiers such as the quantifier, the upside down A, which means for all, or the universal quantifier, the backwards E, which means there exists. It uses these symbols called predicates to describe the relationships between variables. So in this expression on the top right here, you can see an expression that says, for all X, there exists a Y, where X is friends with Y, and X is friends with the mother of Y. Many developments in the linguistic field of semantics actually attempts to see how natural language can be rephrased in terms of this kind of symbolic system. And we also see the ideas of formal logic further developed by Bertrand Russell and Alfred Nord Whitehead, who aimed to describe mathematical logic to the greatest possible extent. In other words, developing a symbolic system which could explain human understanding as much as possible. So to conclude our lesson for today, the machines which are capable of exhibiting human-like behavior have a very long history to them. And philosophers who have seen these kind of machines have recognized their strengths and also speculated on their potential limits. And we also see in the early history of AI that there are many attempts to systematize the way knowledge can be expressed using things like Boolean logic and predicate logic. And these kind of developments were crucial for the development of computer programming, which became very important when computing technologies were developed.